As we ask for our three panelists to come down and join us, I just want to also recognize Barbara Elkis from Clean Air. So come on down. Barbara Elkis from Clean Air Planet, who's here somewhere, I'm sure. There she is. And Russ Funari and Angela Ortiz from PSE&G, the three of them who did a lot of the detailed work and pulling together today. Thank you, Russ. Thanks. Make yourselves at home. We're so pleased with the panelists that have been able to join us today, and we're sad to report that Adam Freed from the City of New York is not able to join us due to a family emergency that came up yesterday. He has shared his presentation with us, and along with all of the other presentations today, as well as the recording of the morning and lunchtime sessions, we'll be making those available to you through the university, through Clean Air Planet, and through PSE&G. Adam Freed and the City of New York have committed to work in conjunction with all of us in moving forward on this issue, recognizing that tackling these issues and looking at the science and public policy associated with climate preparedness is something that's best done in a regional perspective. So I'd like to take a minute to introduce our three panelists today, and as Dean Hughes pointed out, full bios for everyone today are in your packet, so we're going to be short in introducing everyone. I'd like to introduce all three first so we can try to be efficient with our time, and I have the opportunity to keep everybody relatively on time today. First, I'd like to introduce Dr. Anthony Broccoli, Tony Broccoli, who's a professor of atmospheric science in the Department of Environmental Sciences at Rutgers University at the School of Environmental and Biological Sciences, where he also serves as the director of the Rutgers Climate and Environmental Change Initiative. Tony serves as the chief editor of the Journal of Climate, and he's been a contributor and reviewer for the Intergovernmental Panel on Climate Change, the IPCC. Prior to coming to Rutgers, Tony spent 21 years at NOAA's Geophysical Fluid Dynamics Lab in Princeton, which is one of the premier modeling centers in the world. We'd like to congratulate Tony on his recent election to the rank of AAAS Fellow in recognition of his distinguished contributions to the understanding and modeling of past climate change and to communicating climate science, and he will be awarded that honor in the new year. So congratulations, Tony. Wait, you're not getting up yet. I'd also like to introduce Dr. Kim Knowlton, who is an assistant clinical professor of environmental health science at the Mailman School of Public Health at Columbia University. And she's also a senior scientist with the Natural Resources Defense Council's Health and Environment Program in New York City. Kim also chairs the Global Climate Change and Health Committee of the American Public Health Association's Environment Section. Her work focuses on the health impacts of climate change, advocating for strategies to prepare for and prevent these impacts, and making health a more central feature of national, state, and local climate change adaptation plans. She was among the researchers who participated in the IPCC's 2007 Fourth Assessment Report. And just also as a note, just in the last 2 weeks, NRDC has come out with a new study and some really exciting new data regarding economic impacts of the public health aspects of climate change. And I strongly encourage you to visit the NRDC website, which has a lot of data and very easy to kind of follow and understand. And finally, I'd like to introduce the Bloustein School's own Dr. Joseph Seneca, who's a university professor of economics here at the Bloustein School. He's the author of over 200 articles, reports, and books on economic policy, public finance, environmental economics, and state economic development. From 1991 to 2003, he served as the Rutgers Vice President for Academic Affairs, the Chief Academic Officer of the university, and he was responsible for all academic units and programs on the New Brunswick campus. For many years, he served as chairman of the New Jersey Council of Economic Advisors. I'd also like to point out that 2 years ago when Marjorie Kaplan and I started a conversation on climate adaptation with Dean Hughes, Dr. Seneca was also in the room, and we'd also like to recognize his students who are here today in lieu of going to class. So welcome to Dr. Seneca's students. So Tony will lead us off, and then Kim and Dr. Seneca.
Thank you very much, Jean, for a kind introduction and for the opportunity to be here today. Once we get the technology running, go. So my topic today is going to be climate change and its impacts, and I'm going to try to give you an overview of the science, particularly an overview of the science that's relevant to the question of climate change adaptation and how best to prepare for climate change. So starting out with just a few facts about climate science, combustion of fossil fuels emits carbon dioxide into the atmosphere. We're currently emitting about 9 billion, that's with a B, tons of carbon into the atmosphere. This chart shows how carbon emissions from human-induced causes has changed over the past several centuries. Clearly, emissions were very small until around the beginning of the 20th century, have been ramping up rapidly. One of the things that I would call your attention to is the mix of fuels involved. As soon as I can find the button on the laser pointer, it's at the bottom. Okay. There we go. So here's the total carbon emissions rising. We see interesting little things like the glitch here from the first oil embargo in 1973. And you can see that as this interruption in carbon emissions due to the burning of liquid fossil fuels. But what I want to mention in particular is the rapid rise in the burning of solid fossil fuels, in other words, coal, over the last several decades, which has really contributed to this rapid increase in carbon emissions over the past decade or two. So 9 billion tons of carbon going into the atmosphere every year. This is something that most of us aren't aware of because carbon dioxide is an odorless, colorless gas. But imagine if the world was producing 9 billion tons of some other sort of pollutant that we could see. We would probably be more aware of it. We would probably be more conscious of it. Roughly half of that carbon that's emitted as a result of burning fossil fuels finds its way into the atmosphere. The other half finds its way into the ocean, where it causes ocean acidification, which is an environmental problem on its own right. But we have measurements of carbon dioxide here from the Mauna Loa Observatory on the Big Island of Hawaii, going back to the late 1950s. And in the late 1950s, the concentration was about 315 parts per million. We've now pushed on past 390 parts per million. And if you look at the curve carefully, you can see that it's not a linear increase, that it's been increasing more rapidly in recent decades. And of course, that's consistent with the rapid increase in emissions that you saw in the previous diagram. We have evidence from ice cores that shows that the level of carbon dioxide in the atmosphere was very steady at between about 270 and 280 parts per million until roughly the middle of the 19th century, when the rise that we see the last 50 years of here began. Now, the basic physics, why do we care about carbon dioxide and climate? The reason is that there's more than a century and a half of research that has connected carbon dioxide to climate. And the physics are relatively straightforward. The Earth receives energy from the sun. The sun is the heat source for the Earth. We receive that energy in the form of visible light. The Earth also emits energy in the form of infrared light, and this is the cooling mechanism that balances the heating that we receive from the sun in the form of visible light. Carbon dioxide and water vapor are greenhouse gases that absorb infrared light, making it more difficult for the Earth to emit energy to space. So increasing amounts of carbon dioxide disrupt the balance between the energy the Earth is receiving from the sun in the form of visible light and the energy that it's sending back out into space in the form of infrared light. So with more energy coming in than going out, that causes the Earth to warm. And as I said, the physics of this process was understood more than a century ago, long before we had any measurements of the amount of carbon dioxide in the atmosphere or measurements of how the Earth's temperature was changing. But we do have measurements of how the Earth's temperature is changing, and what we have seen is an increase in global temperature of about 1.5 degrees Fahrenheit during the past century. Now, to be consistent, I have relabeled the vertical axis on this chart in degrees Fahrenheit. That's why the numbers look a little bit funky, because I did that old centigrade to Fahrenheit conversion thing. And you can see that the rise in temperature has not been steady. There was a moderate warming through the middle of the 20th century, a bit of a flat period or even a slight cooling from the 1940s into the 1960s, but then a more rapid increase in temperature since then. The focus is not on what the temperature of a particular year was. In this data set, 2010 happened to be the warmest year on record. 2011 will be cooler. We know that for sure because a La Nina event is happening in the Pacific, and when that happens, the climate tends to cool. But we're focusing on the long-term trend here, and the long-term trend is clearly upward. Now, to give you a sense of how this may play out in the future, I'm going to show an animation from a simulation with a climate model starting in 1970 and projecting temperatures forward through the 21st century. You can see the color scale down at the bottom of the diagram here. The blue colors, the cool colors, represent temperatures below the average for the period 1971 to 2000, and then the warm colors represent temperatures above that 1971 to 2000 average. And as I start this up, you'll see the colors changing. This is essentially just the weather, one year being different from the next. And the warming and cooling comes and goes, but gradually, as we get further into the 21st century, we're starting to see less blues and more yellows. We even have some orange picking up from time to time. Eventually, the blue colors become very rare, just a few places exhibiting some of those blue colors, the predominant colors being yellow, orange, and red. And as time goes on, the world continues to warm. The continents warm more rapidly than the oceans. The northern hemisphere warms more rapidly than the southern hemisphere until we get to the end of the century. Now, I'm going to start this again and pick out a location. It can be New Jersey. It can be somewhere else. And you'll get a sense for why we need to take a long-term perspective to see climate change happening. Because as you focus in on one particular place, you'll see the colors changing quite rapidly from blue to yellow and back to blue again. But inexorably over time, we start to see fewer and fewer of the cooler colors, more and more of the warmer colors, and that represents this background warming, that long-term trend that you saw in the previous diagram, which still has fluctuations superimposed on it from the year-to-year variations in climate. So there's no mistaking that when we can run 130 years by in about 90 seconds, that it becomes very obvious that this is a warming world that we're projecting in the future. But as we're experiencing it in real time, it's not so obvious because we tend to be focused more on, for example, last winter's cold and snow than we are the long-term perspective. And you'll hear a little bit more about the long-term perspective if you're in the breakout session on infrastructure with Dave Robinson, our state climatologist, this afternoon. Now, the climate changes that were exhibited in that animation are having a number of impacts on society, on our environment. This cartoon illustrates some of those impacts. I certainly don't have time in 20 or 25 minutes to talk about all of them, but I'm going to focus in on some impacts of climate change that I think are particularly relevant here in New Jersey, and I think will tie in very well to some of the topics that are under discussion during this afternoon. Sea level rise is a very important issue. This is a picture of flooding on one of the barrier islands just associated with the passage of an ordinary run-of-the-mill wintertime nor'easter. That water is probably about a foot or a foot and a half deep in the street there. And I'm using this as an illustration of sea level rise because the impacts of sea level rise are going to be felt primarily in conjunction with the storms that raise water levels by essentially blowing water onto the coastline. Now, sea level rise has many causes. Probably the most photogenic cause of sea level rise is melting of glaciers. This is a glacier in the Alps, the same vantage point taken 22 years apart. So in 1985, the edge of the glacier is right here in the foreground. This is ice. It looks very dirty because, of course, it's accumulated a lot of sediment. And the end of the glacier is usually the area where a lot of melting is taking place. So just like snow gets dirty after it lies in the street for a while and the dirt and dust gets concentrated, the same thing happens in a glacier. But by 2007, that glacier is gone from the foreground. This path here is now this path here. The glacier has retreated far back into the valley. And this is not an isolated event. This is something that is happening for most of the glaciers in the world, the exceptions being some glaciers in areas that have been receiving more precipitation, more snowfall, have been growing, but something like 95% of the world's glaciers have been retreating. Now, melting glaciers are not the only cause of sea level rise. Also, as the ocean warms, it expands, its density becomes lower, it takes up more space, and even though that expansion just represents a small percentage of the volume of the ocean is very deep, so a small expansion can contribute significantly to sea level rise. And in addition to the glaciers in the mountains, we have large ice sheets in Greenland and Antarctica. It seems like once or twice a year we hear about a piece of the Antarctic ice sheet breaking off that's either the size of Rhode Island or Delaware or some other small state. And whenever that happens, it's also contributing additional mass of water to the ocean as that ice melts, and so that causes sea level rise. Here in New Jersey, at Atlantic City, we've seen a little over a foot of sea level rise in the past 100 years. This is a combination of the rise in global sea level and also the subsidence of the land in New Jersey. Places like New Jersey, where the land is subsiding, will feel the effects of sea level rise more urgently than places where the land is not subsiding. Of course, there are places that are worse off than us in New Jersey, such as Bangladesh or Louisiana, where the rate of subsidence of the land is even higher. Those places will feel the effects of sea level rise very acutely. Hydrologic extremes are another example of the impacts of climate change. These are some pictures from the flooding following Hurricane Irene. In the left-hand side there, you do see one solution to the traffic problems on Route 18. But for the most part, they just displaced those traffic problems somewhere else. Extensive flooding, the second highest river levels on the Raritan River, second only to Hurricane Floyd in 1999, with impacts throughout the state. Now, these events, extreme though they may be, cannot specifically be attributed to climate change in the same way that one can ask the question, well, you know, there have been these players in baseball that have been reported to take steroids when they hit a home run. Was that particular home run caused by using steroids? There's no way to answer that question. But what we can say in that case and in this case is that the changing climate increased the probability of certain kinds of events taking place. And these heavy rain events are among the kinds of events that evidence from both models and observations indicate are connected to climate change. Here are some records of flooding on the Delaware River over the past century. These are the number of flood events at Trenton per decade. So in the first part of this record, we see typically between 1 and 3 flooding events per decade. But from 1992 to 2001, 4 events. In the last 10 years, 9 events. So there is an apparent trend here. We can't say that this trend is due to global warming. We, first of all, don't know how representative it is of a larger area. We don't know if the trend will continue. But we do know that we expect climate change to have similar effects. At the same time, climate change is increasing the probability of droughts. Now, the particular quantity that's pictured in this diagram is a little complex to understand and explain. I'll summarize it by saying it has to do with the percentage of the warm season that dry spells prevail. And in the eastern United States, there's been an increasing trend of the fraction of the summer the dry spells are prevailing. So this may seem paradoxical that global warming can produce both heavier rains but also more frequent dry spells. But really the way to understand it is that in a warming world, more water evaporates from the ocean. That water evaporating from the ocean is what makes clouds and precipitation. That precipitation falls on the land, runs off into the ocean. This cycle is going to run faster as the world warms, meaning when there is precipitation, the precipitation is going to be heavier, but during the periods when there is no precipitation, there's going to be more rapid drying because the world is warmer and evaporation is happening more rapidly. So we expect more hydrologic extremes in a warmer world, and these obviously have tremendous impacts on issues such as water supply and also infrastructure. Human health is another area in which we expect climate change to have considerable impacts. This picture is to make you think about heat waves, and heat waves are the most profound way in which global warming will affect human health. The diagram on the left shows the number of days above 100 degrees in different parts of the United States. Here in New Jersey, that number has been very small during the latter part of the 20th century, but it's projected under lower and higher emissions scenarios to increase dramatically. Under a higher emission scenario here in New Jersey, we would expect as many 100-degree days towards the end of this century as were typical in the late 20th century in areas like Texas, Oklahoma, and the southern plains. But temperature, in addition to impacting us in its own right, also creates impacts on air pollution. These charts here show the tendency for ozone concentrations on the vertical axis to depend on temperature for different locations. Clearly, once the temperature gets above a certain level, higher temperatures are associated with higher ozone concentrations. Ozone in the lower atmosphere is an atmospheric pollutant that can adversely affect human health. Projections of future changes in ozone indicate that the scenario will depend very much on whether or not we follow a lower emissions course in which some of the precursors to ozone would also be reduced. And so in that scenario here in the eastern United States, ozone levels would decrease substantially, or a higher emission scenario in which the warmer colors indicate ozone increasing substantially. The warmer conditions themselves, if there were no change in the precursors to ozone formation, would produce more ozone. So whether we find ourselves at this end of the spectrum or at this end of the spectrum depends on what happens to the emissions of the ozone precursors. Finally, agriculture, a picture here of cranberry farming. This is a big crop here in New Jersey. New Jersey and Massachusetts are the two of the leading cranberry growing states in the country. And cranberries are interesting because they require a period of dormancy in the winter that's provided by temperatures that are cold enough to initiate this state of dormancy. And studies have indicated that these chilling requirements for cranberries and also blueberries would not be met in most winters by the middle of the 21st century. So that's an indicator of considerable risk to crop production. For blueberries, there are varieties that are grown farther south in the United States that could be used in place of the varieties that are used here in New Jersey today. But for cranberries, cranberries are really a crop for the cold parts of the country. Here in New Jersey, it's about as far south as cranberries are grown anywhere in the United States. So this is a crop that could be adversely affected by climate change. And I just spent Thanksgiving weekend with my wife's family in Massachusetts, and the local paper in the town that I was staying in had an article about how one of the big cranberry growers in Massachusetts, A.D. Makepeace, has already begun to do some research on the effects of climate change on cranberry production at some of their large bogs that I go walking and jogging past when I'm up there visiting. So it's quite interesting to see that this has caught the attention of cranberry growers in Massachusetts, and I hope it's caught the attention of cranberry growers in New Jersey also. Now, I want to say a little bit about the issue of adaptation versus mitigation. It has been true in the past, at least, that discussions of adaptation have produced a negative reaction in some members of the community because it's been felt that talking about adaptation is giving up on the issue of mitigation. Well, aside from trying to be somewhat policy neutral in my comments here, I want to point out what is the reality regarding climate change. Now, these different colored lines here represent different scenarios of future emissions. The A2 scenario, the top line here, represents something that we might call business as usual, still very heavily dependent on fossil fuel energy as we go forward through the 21st century. The B2 scenario, this blue line, represents a lower emission scenario in which carbon emissions would peak sometime in the next several decades and then decrease towards the end of the century. So whether we are on this higher emission trajectory or the lower emission trajectory, that gives you an idea of how much climate change could be ameliorated by mitigation, by trying to reduce carbon emissions. And I'm assuming for the moment that this scenario represents a practical lower level, lower end number for what emissions can be, given that we can't change our economy overnight when it comes to our sources of energy. So the difference between the late 20th century climate and this lower emission scenario represents the changes in climate that we will almost certainly have to adapt to in the future. So that represents a global warming of about, and again I've converted the scale, of about 3.5 degrees Fahrenheit. So more than double what we saw during the 20th century. So adaptation isn't optional. Adaptation is something that is going to happen. The question is, how well will we be prepared to do what we have to do? A recent article in Science, this is the latest issue of Science magazine, Time to Adapt to a Warming World, but Where's the Science? This is a very provocative article. The thesis of this article is that there are many challenges in trying to do adaptation to climate change because the science that's required is there in many cases, but not necessarily in the form that is most important for planners and policymakers. So I'd like to end by discussing what some of the challenges are of adaptation planning. The first one is that actionable science is needed, and I took this term from some of the speakers who were quoted in that article, which discussed a recent conference in Colorado. Actionable science refers to processed information that can be readily used by engineers, planners, decision makers, etc. I'm a climate scientist. When I talk about climate change, I think of climate change in the terms that are most important to those of us who are interested in how the physical climate system works. But that may not necessarily be the kind of information that works best for people who are planning. There's a mismatch in the spatial scales. Local information is desired for planning. Most of us who are thinking about climate from a climate science standpoint are thinking about climate projections that are valid on larger scales. So, as in that animation that I showed you, we don't usually zoom right in on a small area and ask what's going to happen there, because that's not where our information is most reliable. There are going to be uncertainties. Some of those uncertainties represent things we don't fully understand about the climate system, but some of those uncertainties just represent the coming and going of the blue patches and the yellow patches in that animation that I showed you. We can project what the long-term trends are going to be, but that's not going to be able to tell us what's going to happen in a particular year or maybe even in a particular decade. So with uncertainties being involved, a sophisticated risk management approach or risk assessment approach is going to be required. And then there are things that we know we don't know, known unknowns. How will climate change affect nor'easters, hurricanes, severe storms? Those are areas that are still under active research, and we don't know the answers to those questions as well as we would like. Are there tipping points in the climate system? This is something that people have speculated about. It's not clear if the climate system really behaves that way, but we know that it could behave that way. And we're trying to understand by looking at what's happened in the past, whether or not this can happen again in the future. And finally, more effective communication between the climate research community, people like me, for example, and potential users of climate information. That's something that we need. And of course, that's why we're here today, to begin that process of communicating more effectively. So with that, I thank you for your time.
Thank you, Tony. We're going to hold questions to the end so that all our panelists will have an opportunity to respond to your questions, and we can actually hopefully have a little bit of a dialogue. So I'd like to introduce Dr. Kim Knowlton.
As the slides are put up, thank you for your help in that. That was terrific, Dr. Broccoli. Thank you so much. So I'll advance right here, and here's the pointer. Thank you, everyone. Okay. Thank you for including me in this terrific panel and this day. This is such an important subject, and so important to talk to all of us here about what's happening in New Jersey. To segue to what Dr. Broccoli was talking about, there's so many opportunities now that you all have, that we all have, to discuss how to really try and help move toward creating healthier communities, essentially, because we are, in New Jersey, as in the rest of the country and the world, faced with the challenges of climate change. I mean, it is here upon us. We've seen in the face of the extreme events that have occurred this year, which, as you said so aptly, no one can say that one event is attributable to climate change itself, but taken as a whole, these are consistent with the types of events that communities will increasingly have to face and cope with in the face of a changing climate. So how do we prepare ourselves for more of the same, reduce those effects, become healthier, more thriving communities? Because we can get there. We can become healthier, more resilient places to live. So we want to have those conversations at the same time that we talk about more economically viable communities and how to sort of meet those two challenges at the same time. So we've mentioned a couple times extreme events this year. Notably, 2011 has been a year in New Jersey and the United States as a whole in which there have been, a terrifically terrible burden of extreme events. And I bet a number of you heard the Friday before Thanksgiving, the Intergovernmental Panel on Climate Change, the IPCC, released this report, the acronym SREX, the Special Report on Extreme Events. I'll give you just a few highlights from that. It found that globally, but looking right here in the United States as well, a few of these types of extreme events that have had these really damaging effects on New Jersey this year that have been mentioned already. The heavy rains that have caused terrific losses. New Jersey, we know, had a record wet year this past summer. Record wettest year. Those have caused such pain and suffering. We'll talk some about the health effects, but also in terms of infrastructure damage. As climate change continues, the frequency and intensity of many of those events is projected to increase. Coastal flooding among them, of course, New Jersey being a coastal state. Preparedness can help limit those damages. And as Jean mentioned, I'll share with you some of the findings from Natural Resources Defense Council NRDC study that came out just several weeks ago on looking at and estimating the health-related costs of some of these extreme events today. 2011, this year, is a follow-on to last year, 2010, which also had its own set of extreme events. So we're in a decade and a time of these extreme events that are visiting upon us as a society, as a state, more and more of these costs. This year, to date, and of course we're just at the tail end of November, we've already experienced 14 of the billion-dollar extreme events that the National Oceanic and Atmospheric Administration, NOAA, is tracking. That in itself is record-setting. New Jersey, the state, has experienced its wettest ever August and summer. The cost estimate as a nation of those 14 and counting damages, not including the health costs, which we'll talk about later, is $53 billion and counting. In the prior year, 2010, last year, in the state of New Jersey, heat, just thinking about extreme heat, records, all-time records, those that have been kept since the late 1800s, were set in 8 cities for the all-time record hot temperature, and in 4 cities for the all-time record hot nighttime temperature. Hot night times are especially damaging to health. I'm a health scientist. I'm going to move right on to talking about some of the health impacts, because I'm especially concerned about what these rising temperatures, increasingly intense extreme rainfall events mean for human health. This follows on to a decade. As you can see, the decade from 2000 to 2010 was the warmest decade globally on record, since records have been kept. So these are consistent with the trends that Dr. Broccoli was talking about. And climate change, this whole trace of the effects of climate change in the U.S., this is a matter of record of observation. And I'll just point out from the listing, which is compiled here from the U.S. Global Change Research Program, the facts on the right and floor maps that are put together in the graphic area. I'll mention to you that sea level rise of 8 inches or more in the past 50 years, as was mentioned previously, here in New Jersey, it's even greater than that. It's over a foot here. So in some of these areas, some of these types of impacts, the state of New Jersey is actually running ahead of the national average. Extreme rainfall events in the Northeast, which includes New Jersey, in the last 60 years have been, there's been a 67% increase. So we're watching these trends and we're seeing that we're already in a state of really significant increase. It's been mentioned by Dr. Georges Benjamin, who is the executive director of the American Public Health Association, the largest membership organization of public health professionals, that the link between climate change and public health is one of the most serious health threats facing the nation, but very few among us understand those links and the threats that it poses to the health of our communities and our families today. And I think that it's drawing those connections and connecting those dots that our efforts at NRDC in particular have been aimed at in the last several years. And furthermore, to try and make that story and those links local, to go from those global climate models and pictures and to bring the story of the health effects of climate change into people's backyards and communities. And we've done that with a series of mapping projects and efforts. And I'll share with you some of those results and the means by which you can look at those online and venture in and look in your own communities and see how it bears on the risks and the vulnerabilities in your communities. Because moving forward with this, I think that's how we need to, and each of you need to sort of follow on with this conversation, think about how we look at adaptation and preparedness moving forward. Because we're never going to tell the whole story today in the course of our conversations. There's food for thought in the future. This is you'll see often in discussion, sort of a starting point, the listing of those links, those dot connecting between climate change and health effects. And Dr. Broccoli mentioned a number of these: extreme storm events, heat waves, air pollution, notably ground level ozone air pollution. It's called smog often. But some of the perhaps more subtle ones are less obvious. Pollen and plants that produce pollen, which of course is for people with allergies, can be terribly bad news for health. I'll talk about that. The connection between carbon dioxide concentrations, the main greenhouse gas, waterborne illnesses, foodborne diseases. We won't talk in great detail, but perhaps the last 4 items may be those with the longest term impacts, with perhaps the biggest economic cost on society as a whole, and maybe the most elusive to capture. Ecosystem impacts, food and water insecurity, mental health impacts. How are we going to capture the long-term effects on our children's, on our families' mental health in the face of these very sobering changes in a future world? And environmental refugees, that's the term given to families, businesses, individuals displaced from their home sites. Whole villages we've seen in New Jersey and upstate New York, Vermont, that had to leave their place of origin or their site in the wake of Hurricane Irene for an extended period of time. How do we wrap our arms around those social costs? This is a very important point. Vulnerability to climate impacts. There are a number of points that we understand about who is most vulnerable to that wide range of the health impacts of climate change. And there's some convergence, but this is a story that we need to sort of tease out and look in at the local level. We understand that here locally in the United States and globally, people and communities that are economically disadvantaged are among the most climate vulnerable to that range of effects, to that range of health impacts. People of older age and younger age both are most vulnerable, in part because of a tendency to more pre-existing health conditions, perhaps in the older population, a greater propensity or prevalence of lung or heart illnesses, which can make people more prone to heat vulnerability. Children are more dependent on other people for mobility. In case of a storm event, location definitely affects people's vulnerability. Coastal communities, obviously, are more at risk from sea level rise and storm surge. People in cities from heat waves and urban heat island effects. The materials, the building materials within the city absorb the daytime heat and re-radiate it at night. So it's the sense that ambient temperatures in the city can actually be warmer at night. But these vulnerability factors go way beyond this list. There's more subtle sort of social factors that go into local vulnerabilities. And we really need to zoom in and look more in detail and work with communities. And it would really pay to do more local studies with the impacted communities. No one knows better than the affected communities about what the local social vulnerabilities are. It goes way beyond race and class and economics. We need to do more of those studies. Here in the U.S., there's a long history of heat waves and hurricanes being those that are among those that cause the greatest, is it the one on top, I hope? Yes. Hurricanes and heat waves are those that cause the greatest heat-related, or rather weather-related fatalities in terms of both the 10 and the 30-year averages. And of course, New Jersey, a coastal state, one with a lot of cities, is at risk from both of these types of events. If we counted the sort of heat-related excess mortality, the numbers here would be far greater than this. Some estimate that the numbers would be 10 times this if we looked at the whole range of heat-related mortality. There have been a set of projections of New Jersey's future health-related effects of climate change under a changing climate. This is by late in the century. I feel like this battery is getting a little weak, but we can just get a sense of what those warmer temperatures will mean. As Dr. Broccoli said, there's a sense that in New Jersey, thank you. Oh yeah, this one has a stronger pointer. That in New Jersey, the climate, the temperature by late in the century could be more like that of current day South Carolina if we proceed on a higher emissions scenario. In other words, if we don't trim our carbon pollution, which is actually triggering the greenhouse effect and these higher temperatures. Increased coastal flooding, sea level rise of another 2 feet or more. That's a more rapid rate of change than we've seen in this last century. And what's now considered the once-in-a-century flood in Atlantic City could happen every 1 to 2 years. That's a dramatic change in the flood return, and that has terrific consequences on infrastructure and on people's livelihoods. I'm going to show you 2 slides, one from a heat-related mortality study and the second from an ozone smog-related mortality study that I participated in with my colleagues at Columbia University at the Mailman School of Public Health. So this shows a tri-state area that includes part of southern New York, part of northern New Jersey, and part of western Connecticut, sort of the classic metro tri-state area. We looked at how climate change, warmer temperatures by the 2050s could affect summer heat-related mortality, and what we found is, in the region as a whole, that could increase 70% by the 2050s, holding everything else constant, holding the population of the region constant, if we don't do something to trim carbon pollution and climate change. We found, too, that adaptation, or the steps that we take to prepare, matter. If we made assumptions that are sort of the counterpart to preparedness steps, we reduce that overall mortality in the region by an estimated 25%. So what we do today really matters. As was mentioned before, rising temperatures increase ground-level ozone smog, which is harming to health. It's a respiratory irritant in the lung. Some people have likened ozone to getting a sunburn on the lungs. This comes from a different study. This one was published in 2004, but it's the same study area, western Connecticut, southern New York, and northern New Jersey right here. Here we see an increase in summer ozone-related mortality. In the different counties, you can see that there's regional differences. These numbers are the relative increase relative to the 1990s of summer ozone-related mortality. And interestingly here, and cause for some concern, we see in some of the counties of central New Jersey some of the highest rates of increase relative to today, the 1990s being sort of the counterpart for the present, in summer ozone-related mortality. As temperatures rise in future with climate change, ozone concentrations increase, and thence ozone-related mortality. Another type of air pollutant, aeroallergens. Ragweed is found across New Jersey. We found 9 counties of New Jersey report both the presence of ragweed and, in a typical summer, unhealthy concentrations of ozone. Think of late summer. That tends to be when there's the most reports of those high ozone days, ozone alert days. Unfortunately, late summer days are also when ragweed begins to produce pollen. So late summer is a time when there's these co-exposures of ragweed and ozone. Ragweed, unfortunately, responds to higher CO2 levels. In some laboratory studies, ragweed grown at today's levels, these higher CO2 levels, already is producing double the amount of allergenic pollen. And grown under the concentrations in a future change climate, those levels of CO2, over 4 times as much pollen production. So this basically comprises the potential for a double whammy, if you want to think about it that way, to health. We did a mapping study at NRDC of the areas of the U.S. where those 2 potential health risks are co-located. The areas here that, it's a little hard to see, but these are raised areas here where the 2, ragweed and unhealthy ozone days in summer, both occur. There are 110 million people living in the U.S. currently where those 2 health risks occur. In the future, as CO2 levels rise, as temperatures and thence ozone concentrations rise, those health risks could increase as well. And that's bad news for people with asthma, with allergies. There's hundreds of thousands of people with those conditions in the state of New Jersey. And across the U.S., there's an estimated 25 million people with asthma now. Infectious diseases, dengue fever is one of them. There's concern twofold related to climate change. One, as temperatures increase, those infectious diseases that are carried by vectors, those insects that can carry diseases like mosquitoes, could potentially increase their range or their period of activity, the period in which they can bite humans, and if they are infected with an illness like dengue fever, which is a viral illness, potentially transmit that illness to human beings. We did another mapping study of dengue fever in the United States and found that there were currently 178 million Americans living in these red-colored counties in which one or both of the two mosquito species that can carry dengue fever currently occur. Many people currently travel to areas in which dengue fever is endemic, is found, come back to the U.S. with an infection. Unfortunately, it's therefore possible for people to be bitten during the mosquito's active period in summer and potentially infect the mosquito transmit it to someone else. In 2009, new outbreaks of locally transmitted dengue were reported in Florida. Dengue is locally transmitted in the Texas border region, concerned that it could begin to move northward. Now moving on to the costs of climate change, the costs associated with this range of health impacts. In past, these types of health costs have not been part of the damage estimates of climate change. We considered that an oversight. What we did is look at the literature, the current literature on existing extreme events. We looked at the peer-reviewed literature or agency reports in which emergency department visits, mortality, hospitalizations had been assessed already, and working with economists at the University of California, we came up with one method, a standardized methodology to attach costs to each of those 6 events, 6 types of case study events of the types that are projected to increase in frequency, intensity, duration with climate change. Heat waves, wildfires, river flooding, hurricanes, these types of events, these 6 events. What we came up with is an estimate of $14 billion. This is just from those 6 events. This is not knitting together the story of all the events that occurred between 2002 and 2009. This is the time period of the 6 case study events. We feel that this is a rather conservative estimate since it's just these 6 case studies. This shows you the site of the 6 case study events, ozone smog pollution nationwide, Red River flooding in 2009 in North Dakota, wildfires and heat wave in California, a West Nile outbreak in Louisiana, and in Florida, the 2004 hurricane season. This gives you a sense of how the illness versus premature death valuation broke out for those 6 case study areas and the total cost in the 6 case study areas. The full paper, which appeared this month in Health Affairs magazine, is available by a link at this site, along with the fact sheet that summarizes those findings. So you can see the full methodology there. And the map. And dig in. To summarize, there's mitigation, adaptation. Dr. Broccoli, you stated nicely the case that these two must go hand in hand to limit the most severe, to reduce the unmanageable effects of climate change, as some people say, and to manage the unavoidable, we adapt or prepare. We're using the word preparedness more in the public health frame now. A sister site to the economic analysis paper that we just brought out is this one. This is the URL for the maps of the 50 states in the District of Columbia, nrdc.org/climate maps. This is the site in which you can zoom in to 5 national vulnerability maps, including the ozone and ragweed air pollution map, the dengue fever map, flooding, drought, and extreme heat are the other 3 vulnerability maps. Zoom in, look at the vulnerabilities down to the state, county level, but very importantly, look at preparedness steps that are or are not happening in response to each of those vulnerabilities. When we try and think about or structure preparedness responses to each of those, we think in terms of these 4 frames. identifying local vulnerabilities. Who and where are the most vulnerable individuals or communities in terms of each of those climate health risks? Then it's very important to track environmental changes that are affecting and threatening local health, and to watch or conduct local surveillance for outbreaks, for local health threats, for changes in local asthma rates, to build resilient communities, to talk to local communities that are being affected today, to learn and listen to what needs to happen in the communities, to make changes to housing, infrastructure, transportation, and lastly, to promote education and public dialogue like today, like the workshop, with policymakers, with the community, with communications experts. This is essential. With health practitioners, another very important community and means of getting the messages to people. Just one example of a really successful health preparedness approach that's been taken are heat health warning systems to help communities respond to heat waves when they occur. There are 18 of these systems now in place across the United States. They really speak to each one of those 4 elements of climate health preparedness. To promote adaptation, I'll just note that when we did that survey of the 50 states in D.C., we discovered only 13 states have climate health preparedness plans or elements now in place in their state plans. Only 13. New Jersey wasn't among them yet, but could be. That means that 37 states have a long way to go and can get there towards making healthier, more secure, more resilient states and communities. There's lots of communities making local steps towards climate health resilience. There is a proposed piece of national legislation that Representative Lois Capps recently proposed to try and build climate health infrastructure and support these types of measures. We really need to continue this conversation to try and prioritize this discussion in planning efforts, to get continued support for creating and supporting national databases on climate-sensitive events and health outcomes. The National Environmental Public Health Tracking System is out there. It's terrific. It gives people like all of us the means to find those local health outcomes that are happening in each of our communities and say what's happening in the way of heat-related illness, mortality, West Nile, locally, and then track what's happening. And we're building a knowledge base right now on adaptation in local communities. Because, again, we need to prepare at the same time that we reduce carbon pollution to create those healthy communities. The two have to go hand in hand because health is of utmost importance to everyone. By doing so, we will get to the healthy, resilient communities we need that New Jersey, has always supported, and will just create a healthier set of communities and state. And with that, I thank you and invite you to visit and ask any questions either in conversation or by email. So thank you very much.
Again, we'll just hold questions towards the end. And I'd like to introduce Dr. Joseph Seneca.
Thank you, Jean. Okay, good morning. Why do they always say the economists for last, right? They're boring, right? So we had those exciting lectures with Tony, whom I always enjoy hearing. I always learn so much from him. And it was terrific, Dr. Knowlton. My students know your paper. This issue of valuing those health benefits is a very key part of our course. And I'm pleased that my students are here this morning in lieu of class. It's to their benefit, obviously, in lieu of class, but to get a sense of the entire scope of policy issues beyond the economics. So again, I thank them for coming this morning. Just a couple comments on what I've heard before I do my remarks. Isn't it interesting? I thought that the alignment today of this gathering here in New Brunswick, New Jersey, to address Tony said, at the local level, while he thinks in these global models and the simulation of those climate effects over time and over the whole globe. But we gather here in New Brunswick, and yet a hemisphere away and an equator down. There's a gathering in Durban, South Africa this week as the United Nations Conference on Parties on Climate Change meets. It's COP meeting number 17. It began over 2 decades ago and culminated in 1997 with the Kyoto Protocol with its ambitious targets for the 2012 agreement through 2012. And although 2012 is coming and there's no extension or renegotiation of that, and they are engaged, 194 nations are engaged in that process, and we are engaged here in a process at the local level and the linkages between them. The UN Conference of Parties faces a daunting issue of the divergence between the interest of developed nations and developing nations, the obviously thorny questions of who is going to pay, hence the economics of it, as well as the concern about getting international agreements at a time of, as Gene Hughes noted, deep global economic uncertainties, and the economic constraints become ever more binding. And so those themes ran through my mind as I heard my colleagues this morning, and just the logic of what's on the panel today. Dr. Broccoli looked at the global picture, but then came back to the issue of local planning and local decision makings in the context of those global forecasts, and parsed out the adaptation and mitigation. I thought that was really terrific with respect to degrees of warming and the interesting conclusion that a more significant part of the adjustment has to come from the adaptation end, even under the most optimistic control of emissions. And then Dr. Knowlton, with her health and morbidity and mortality, something that I'm familiar with, and certainly my students are, in going to the transition to the economics. You saw the $53 billion in damage estimates from the floods. I thought that juxtaposed nicely with the estimate of retail sales in the United States on Friday. This is, to show and now the additional issue of Dr. Knowlton stressing the costs of those impacts, both the morbidity and the mortality costs. But the obverse of that coin is the damages avoided if we can either mitigate and or adapt in effective ways, and then the cost of mitigation and adaptation relative to the costs avoided of not doing that. And that's where the economics comes in. So here we go, and my assignment is given to me by Gene and Marjorie, is to discuss the concept of ecological or ecosystem services. That is, the identification of the services, or perhaps in the more economic word, the benefits provided by natural environments, and the measurement of those benefits in monetary terms. The need to monetize ecosystem services has long been recognized by economists interested in non-market activities in order to trace their effects on prices, costs, output, and resource allocation. But it is also imperative for those gathered in this room today, planners, public officials, elected leaders, who daily find themselves facing economic development and public policy decisions that can profoundly affect land use, natural environments, air and water quality, the ocean, the climate, and then on the economic side, employment, income, output, and tax revenues. There's a very large economic literature that measures the dollar value of the eco-services that flow from the natural environment. But to understand the purpose and the findings of that literature, it is necessary to begin with what economists call natural capital. Use that word as distinct from human-made or physical capital. The latter being the equipment, the computer technology, the machinery, the office buildings, the factories, the infrastructure of highways, railroads, airports, ports, etc., Such human-made or physical capital, with which we are readily and all very familiar with, that capital generates an annual economic value from the flow of final goods and services that such capital assets help to produce, and from the employment, income, output, and tax revenues that production subsequently generates. But economists over the last several decades have conceptualized and analyzed the implications of natural capital, a symmetric concept to physical capital, namely that there is an annual flow of economic value generated by natural assets, forests, wetlands, beaches, clean oceans, lakes, rivers, estuaries, tidal areas, and a stable climate. Thus, the word asset, there's the economics, is used for natural capital symmetrically to its more familiar application in the financial world of human-made physical capital. These natural assets that I've just mentioned also have economic value, and they generate, as does physical capital, an annual flow of valuable outputs to society. On the entrance hall of the American Museum of Natural History in Washington, D.C., there's an insightful and prescient quote from President Theodore Roosevelt, who, in 1907, over a century ago, said, quote, "The nation behaves well if it treats its natural resources as assets, which it must turn over to the next generation increased, not impaired, in value." One implication from President Roosevelt's comment is that there is a need to maintain the environmental integrity of these natural assets. If instead natural capital assets deteriorate, in the economist language, they depreciate, economic costs or damages ensue. That is, there would be a loss of some or all of the flow of value from the eco-services created and generated annually from natural capital. Let's examine as an example the New Jersey shore with its extensive beaches, bays, estuaries, and tidal marshes. The economic and demographic development pressures over time on the New Jersey shore of more people, more housing, more roads, more infrastructure, and more commercial space have placed ever-increasing environmental pressures on the ecological and natural integrity of the coastal region of our state. But these are the very attributes that attract the development in the first place of the Jersey Shore. That is, the natural capital assets of the beaches, the clean ocean, the tidal bays and estuaries, the marshes, the open space, the natural life systems. These are in turn then threatened qualitatively and quantitatively by the degradation of air, water, and land accompanying that development, or that would occur, as both Tony and Dr. Knowlton mentioned, from sustained global warming and climate change. An ultimate manifestation of such deterioration would be a large, steady sea level rise that would fundamentally alter and severely damage the existing natural capital assets of interfaces of ocean, beach, marsh, bay, and estuary. This would necessitate large-scale and inevitably, from the economist's perspective, costly adaptation measures to counter the rise in sea level and other climate change effects that have been so well mentioned before: storm frequency and intensity, changes in extreme temperature patterns, changes in the amount and timing of rainfall. It is a highly difficult task to design and implement effective public policies to manage the environmental integrity of this natural capital, and especially to implement effective policies to adapt to global climate change, a task that is equally complex to the task that Tony and the climate scientists engage in understanding the climate system. Now here's the economics of eco-services. The natural capital assets, as I defined them broadly in our example, was the beaches, ocean, bays, estuaries, wetlands, and land-sea interface, the stable climate, provide an annual flow of benefits to individuals, to the economy, and to the broader society. These benefits take two forms. They take the form of physical goods, that is, physical outputs, commercially harvested fish, shellfish and plants, minerals. And the focus today, however, is on the services, such as multiple forms of outdoor recreation, beach going, recreation fishing, boating, bird watching, nutrient recycling, water filtration, buffering from storms and flood surges, aesthetic amenities, maintenance of biodiversity, and stabilization of the climate. Most of these benefits from natural capital that I've listed here are use benefits. That is, the natural capital generates an annual flow of valuable services that are used by society. But benefits can also consist of non-use values in the economist language. The preservation of biodiversity, the existence value of species, and the bequest value. These latter benefits occur because of the presence of natural systems and the innate value of that presence. For example, we as a society value the existence of an undamaged natural environment and wish to bequeath, as President Roosevelt noted, that natural capital undiminished to subsequent generations. Now, this flow of eco-services occurs continually, and in economic terms, it has a monetary value to all those things. That is, it is symmetrically a financial return on capital. These benefits can be measured in dollars, and the goal of such measurement is symmetric in principle to the goal of measuring the economic returns of a conventional financial or physical capital asset. A standard financial question. We ask it as individual household members. We ask it as an institution managing portfolios. What is the annual flow, the dollar flow generated by any specific asset? If we are able to answer that question, that generates highly useful economic information. For example, comparisons can be made across assets. That is, which asset produces the highest rate of return. The answer can also inform the efficient, economist language, choice among assets. That is, in which asset to invest, either as an individual or for our purposes today as a society, limited, finite resources. The answer also allows trade-offs between different uses of the natural capital to be evaluated on a common denominator basis. Finally, the answer allows for the asset itself to be capitalized. That is, valued in the total value of the asset. For example, suppose you owned a financial asset, a bond, that provided a return of $5,000 per year in perpetuity. British government sells such bonds. They're called British councils. We don't have infinite annual bonds. We don't have a bond with an infinite life, but we simply float the debt over and over and over and again. It's equivalent to the same thing. So we know the number that we got the $5,000 return per year in perpetuity. If the interest rate on assets of a similar risk was 5%, if interest rates on assets of similar risk was 5%, that implies the present value of this asset is $100,000, and this is obtained arithmetically by simply dividing the annual return, the $5,000, by the interest rate of 5%. The key to determining the value of the asset, which is what we have just done here, the value of the bond, is that you need to know the annual economic return generated by the asset. In this example, that $5,000 number. But here is where we begin to encounter complexities when we try to take this conventional financial market calculation into the realm of natural capital. First, the benefit has to be identified. For example, flood damage avoided from the presence of wetlands, or the recreation benefits from the beach, or, in Dr. Knowlton's case, the dollar value of premature deaths and morbidity avoided. then the value of these benefit flows must be measured in dollars. Now, when there are market prices for the eco services generated by the natural capital assets, the task is relatively straightforward. For example, there is an existing private market where prices are determined by supply and demand for commercially harvested fish and shellfish. And the dollar value of the catch, the fish catch, adjusted for the cost of other inputs besides the natural capital of the marine environment, the clean marine environment, is a ready and valid measure of the annual dollar value of the output, the fish in this case, generated by the natural capital asset, the clean ocean, the fishery. The existence of a price in that case, in that market, means that there's a measure of what economists call willingness to pay. That is, consumers place a value on the good, it's assumed, at least is equal to the price that they willingly pay for it. That's a rational market transaction. That transaction wouldn't occur if the harvested fish were not at least equal to the consumer, the value that they paid for it. They wouldn't buy it. However, when no private market exists for the output of the ecosystem, valuation becomes much more difficult. For example, what is the value of a day of surf fishing off Island Beach State Park? Or a day of bird watching at the Forsyth National Wildlife Refuge? Or a glorious, sunny, lazy July day with friends and family at any New Jersey beach? Or even more complex, the value of the tidal marshes of Barnegat Bay for the protection they provide against storm surges, or the value of preserving biodiversity, stormwater control, and nutrient recycling in the functions of Little Egg Harbor Inlet and Bay. In these cases, no ready measure of market price, that is the willingness to pay of participants, exists for valuing the eco-services provided by the natural capital assets of the Jersey Shore. Economists have developed a number of methodologies to infer such values in order to derive the dollar value of the annual flow of ecosystem services from natural capital. In the case of outdoor recreation, such as the beach going and the recreational fishing and boating and bird watching and water sports, economists have used several methods that attempted to infer the monetary value of the activity. One method uses travel costs, and the argument is this way. How much do beachgoers, for example, spend to get to the site, to get to the beach, in time and in money? Thus, that amount must reveal a minimum of consumers' willingness to pay at least that much for the day's visit to the beach. Another technique is stated preference, or here on the slide, contingent valuation. That is, through carefully designed surveys, questions are asked to infer the value of a day's recreation based on the characteristics of the beach visitor and the characteristics of the recreation site. Another method is the hedonic price method that infers various values of attributes of an asset. This method has been heavily used by economists in examining, for example, housing markets. It can identify the individual effects of the many varied characteristics of a house, the size of the house, the age of the house, the number of rooms in a house, the amenities of the house, the quality of the school district, the quality of the public services that determine its value, including its proximity, for example, to natural capital, the beach, the bay, the ocean, or a natural capital asset. The study that Dr. Knowlton authored used the economist technique of hedonic valuing to measure the value of a human life, really not measuring the value of human life, but measuring in the dimension of her metric there, the value of a premature death avoided. And economists use hedonic studies from labor markets to infer that value that is used in these typical studies that value the benefits of any life-saving or mortality-reducing activity of public intervention, in this case, adaptation and emergency preparedness for climate change. Another methodology measures the annual value of the ecosystem services provided by tidal bays and wetlands as storm buffers, for waste assimilation, and for nutrient recycle. This last line on the slide, these are avoided costs. The avoided cost valuation methods estimate the property damages avoided, for example, from storm buffering, and or the replacement cost of water treatment infrastructure or water protection infrastructure that would have to be provided publicly in lieu of the services provided by natural processes of the wetlands and the tidal marshes. For climate change, consider sea level rise, as discussed by Tony, and adaptation to it for the New Jersey shore. And here I wonder a bit, and I trespass into my good colleagues' areas, to Ken's area and to Tony's area, so I hope they don't arrest me for practicing without a license, okay? Please don't do that. And I do this with some trepidation, but I did do peer review. I ran this by my good colleague, my good Rutgers colleague, Dr. Norb Sudi of the Institute of Marine and Coastal Sciences at Rutgers, and these are his several slides, just a few slides. Here, I just found this slide, which I saw last June at a conference both Tony and Ken and I participated in, which has some of these elements today, in terms of my comments at least. I just found this slide, it woke me up and startled me. And this is a slide, again, by my Rutgers colleague, Norm Sudi. This is Long Beach Island. Looking north into Beach Haven, those of you who know the area, from the Holgate section of the Forsyth National Wildlife Refuge. Note the difference between the natural beach and then New Jersey wall-to-wall development, right? From beachfront to bay. Note the migration to the west, inland, of the natural area. And as Norm tells me, as beach sediment, that means sand to us, sand, and sea level rise, the dynamics of beach sediment and sediment accumulation, and yes, sea level rise, as both Tony and Kim noted, is occurring at approximately 4.3 millimeters per year in New Jersey, has pushed the beach, the dunes, and the back marsh inland, just migrated to the west. Migrated inland, maintaining the same ecological features of beach, dune, and marsh. Now note the sharp contrast to the developed part of Long Beach Island, where adaptation measures of groins, that's jetties, and beach replenishment. I don't know if you can see the jetties in here, and they go all up. They're all up the beach. Those jetties and groins and the beach replenishment have attempts to halt that migration and defend the island on the edge of the built lots. However, the natural dunes and beach are diminishing in that developed section. The beach there is narrowing, and the beach to ocean profile is steepening. There's a strong potential, again according to my colleague, that a breach may occur, a breach in one of those storms that has been talked about. A breach may occur right here, as has occurred in the past, with a combination of storm and sea level rise, but added together over time. And that breach would separate the bottom part of the island, the natural area to the south. The human intervention in the sediment flow, the sand flow to the south, that is trying to block it as it's coming down, will also mean the attenuation of the natural area and its eventual disappearance. And here is the likely future for the developed area over time. The static land use defending the coast and the dynamic coastal system and the steepening of that beach profile. What should guide adaptation policies such as retreat, further defense, or some combination of these? The economic perspective would examine the value of the eco services lost, that is, the value of the beach recreation and other activities, with what will surely be ever-increasing cost of defense in such situations. Based on and I found this number staggering, and it's a reasonable estimate, New Jersey has approximately 41 million annual beach visit days a year. So ranks fourth in the country in terms of beach visit days, and the states ahead of it are warm weather states. Florida, California, Texas, and Hawaii. But New Jersey is fourth. The total number of beach visit days. If you've ever been to the New Jersey Shore, all 41 million are next to your blanket, typically, right? I've estimated that the dollar value of those days, that is, going from days to dollars, monetizing the services of the beach visit, the equivalent of willingness to pay from a variety of those types of studies, basically that one based on travel costs and contingent valuation, is somewhere between $219 million to $1.2 billion a year. It's unpriced, you can't find it, but that's the value generated by the natural capital being able to have those beach available for visits. Interestingly, and more nuanced and more complex, a large additional loss may be the eco services from the attenuation and eventual inundation of the natural sections of the beach, dune, and marsh, and the loss of the existence value of New Jersey's few such remaining natural areas, such as the one in Professor Sudi's slide, along what is otherwise a totally developed New Jersey coast behind the beaches. The resulting policy implications are likely to be difficult, but the identification and valuation of eco services can contribute to making rational decisions given scarce public resources and multiple competing uses as climate change, sea level rise, sediment dynamics, and subsidence, as Tony mentioned, continue and will possibly accelerate. Here are some references for you. They're in the slides. As Gene has indicated, they'll be available. These are different studies that look at the valuation. The last one there is a very interesting one on valuing ecosystem services. And thank you for being an attentive and cooperative audience. With Gene, we're on time and on budget. Thanks.
As much as I'm really sorry that we didn't have Adam Freed from New York City here today, I am very happy that we had a few extra minutes for our wonderful panelists to be able to give their full presentation. So please join me in thanking all three of them for these inspiring presentations. We do have about 10 or 15 minutes for questions. If you could identify yourself, and you can address questions to the entire panel or to a particular panel member, and you can just raise your hand and I'll call on you. Questions? Rob Graff.
Yeah, I'm Rob Graff from Delaware Valley Regional Planning Commission, Philadelphia. I wish we had some behavioral scientists here as well, because it seems that individual benefits accrue from the exact same activities that cause societal and economy-wide decline related to get transportation, they get cooler houses, they get beach houses, and so how do you square those two, I guess is the question. What are some about how to align policies so that there's not a conflict between the individual benefit, one direction, societal decline, going in the other?
Well, let me take a brief. The economist approach would say you need to measure both the private and the social benefits and costs to make rational comparisons. Right now, what markets would measure are a lot of those private benefits that you refer to without accounting for the damage costs. So a proper allocation of resources between public and private use would need to be done by a more complete calculus of the accounting of measuring these, either the damage costs from not taking action or the avoided costs of taking action. And therefore, if you want to, on that spectrum of a lot of private goods and services relative and public damages or everything associated with climate change, there's too much on the one side. Too many $53 billion consumer days and not offsetting it with investing in avoiding these public sector costs, which affect everyone. I'm a consumer, I'm a beachgoer, I'm a taxpayer, I'm an employee. It's not an us and them, it's all amongst ourselves.
And I would just point out that, and maybe I'm at risk of practicing without a license here too, but I would point out that the reason why those costs are there is because we happen to have a source of energy or a primary source of energy that emits carbon dioxide and has a climatic impact. Some of the same activities you're talking about, while they might have other undesirable environmental effects, the climate-related undesirable effects are due to the fact that the energy comes from burning fossil fuels. So you could have many of the same benefits, but without those costs imposed on society if we had other sources of energy to displace fossil fuel energy.
Yeah, and as a health scientist, I'm thinking about the health costs that are externalized that aren't built into the picture, and what would be gained by bringing those into the accounting. And it would be easy if the energy sources were changed to change the behaviors. I'm a health scientist, not a behavioral scientist, obviously. It'd be easy to change, I think, human behavior at the community or family household level. I'm also an optimist. I don't have a license. I think that once the health benefits that could accrue are known full well, because the link between climate change and health, we're still struggling to get that information out there. I mean, that's the work. But I think that behavior could change once that's known. But it's getting those externalized costs built into the picture. Then I think it makes a compelling argument to change energy modes.
And the key, let me marry those two comments, those two very good comments. The key to doing that would be to get a price on carbon. And without that, it's going to be very, very hard. The UN is wrestling with that, and I want to commend PSE&G with its enlightened leadership and approach to this policy. They favored, 2 years ago, a cap-and-trade system and supported it publicly, a major utility that has carbon fuels in their portfolio, along with renewables and nuclear. But until that happens, I think it's a very, very daunting task. Some countries have taken the lead here. Australia just passed a cap and trade. The state of California is going ahead with a carbon tax and cap and trade. British Columbia, New Zealand, Norway, all of those have placed prices on carbon. It's a tough road to see how we're going to get there in the current climate here.
Thanks. How about other questions, Eric?
Yes, Eric Spencer with PSE. Two of us are scientists at Lancet Services come up a few times.
So Ken, where are you? There you are, Ken. You can jump in if I mess this up. But the two main reasons are that during the Ice Age, there was this big hunk of ice sitting on the northern part of North America. And the ice actually pushed the Earth's crust down in the area where the ice was sitting. And just like if you sort of push down on something that's flexible, it bulges up just beyond where you're pushing down. The land here in New Jersey, being just beyond the edge of the ice sheet, bulged up. Now the ice is gone, but the crust doesn't rebound quickly like a trampoline. It rebounds slowly. So our crust is sinking because the weight of the ice has been lifted. At the same time, the extraction of water from aquifers for drinking water and other consumptive uses is also lowering the ground level. How'd I do, Ken?
Ken, any additions? Okay.
Good.
We seem to have a lot of practicing without licenses this morning.
I'm Laura Schwab from the New Jersey Conservation Foundation, and I would, Dr. Broccoli, I would suggest or would like your opinion about, I think one of the challenges to adaptive planning is cross-discipline, having everybody hands, you have an emergency prepared. What are the incentives to get everybody together for adaptation?
Sounds like you're asking me to be a planner without a license in addition.
But just some incentives for the disciplines to work together and make sure they're professional that's
Yeah, I think in the academic world, which is what I feel comfortable talking about, as Dean Goodman mentioned during his remarks at the beginning of the day, I think there has been a general recognition that we have to work across disciplines to try to not break down this problem into separate pieces, but to think of it more holistically. And I guess to some extent, it's more a question for planners and behavioral scientists to answer why, what society has to do to, instead of breaking down problems into separate pieces and stovepipes, to get people to think of these issues more holistically.
And that's actually a very specific question that we'll be asking all of you to tackle this afternoon in the breakout sessions.
I would suggest it's policy too, policy and leadership.
Michael Catania?
Right, County Conservation Resources. Many of us thought we would have a national cap and trade system that would help people out of this. We said for participation in a regional compact, and now the implications of New Jersey going alone without being.
Well, I mean, the need for individual states to take action, I think, is imperative because of the very reason that you cited, the breakdown at the national level. And looking into the short horizon, at least I can't see a price on carbon emerging nationally in this country, either from a cap and trade and or carbon tax. So you have to, from individual actions, do that state forcing. California has done it. California did it with the auto emissions of fuel efficiency and standards and forced federal action ultimately. I think the role for states in general for aggressive environmental policy and climate change policy is ever more stronger. The impact is minor. Tony and I have this ongoing debate because we're part of an NSF project on, even if New Jersey can mitigate a significant part of its emissions, the effect on the climate, Tony tells me, is zero. Should we not do it anyway? Well, the idea would be to force the policy, and by doing that individually and replicating that over frequent individual actions at the state or regional level, you can get an effect. And learning how to do that is important as well. Europe has been very enlightened, and despite their economic troubles, the EU, despite all its difficulty, is still stepping up to the plate and offering to increase its mitigation targets. So I think you need to, where these islands exist of policy action, it's very important for states like New Jersey to continue to pursue it.
Can I take a run at that one? Because I think it's really important. There is so much, even if the state doesn't have an active program statewide happening, there's so much happening at the city and county level. There's so much happening across the country. There's the EPA regulatory, the EPA is now charged with limiting carbon pollution under the Clean Air Act. That is a mission that is going to be actively pursued. Every one of us who are interested in that needs to stay tuned and be mindful of that and support that. I mean, that is where it's going to be happening. But there's so much happening at the local level that is really important, and I think even those percentage point of reductions matter to be cohesive and coherent with what's happening globally. Because, behavior follows, and belief follows behavior, and we're part of a global whole. And we need to be there.
Thanks. Jeff Perlman?
Hi, I'm Jeff Perlman, North Jersey Transportation Planning Authority. Question for Dr. Broccoli. You showed a couple of global climate models, and can you comment on the state of the science for downscaling those models to a regional, more importantly, local impacts? You certainly use embedded into that statistical or dynamic downscaling, because as we just heard is adaptations local, and I think a lot of county and local officials are going to want to know what science can we use to inform our planning processes.
Yeah, Jeff, that's a great question, and that's what I was implicitly referring to when I talked about the mismatch in scales between our global climate models that give us, we think, the best information about how climate will change, and the scales on which policymakers, planners, engineers need information. I think that right now the best way to do that is still a research question. We don't have a simple answer for what is the best way to downscale information. Downscaling is the jargon that we use in the climate community. There are statistical approaches. Some of these statistical approaches have worked very well in doing the daily weather forecast for what it's going to be in New York versus Philadelphia versus Atlantic City versus Sussex County. But we don't have an empirical basis for knowing how well those statistical methods work. Because, of course, weather forecasts, you make them every day. If a method works, you can tell if a method works better than previous methods or if it's less successful. For climate, it's a little hard to know. The other approach is what's called dynamical downscaling, and that's trying to run a model with higher spatial resolution, grid points that are a lot closer together. But that is also a research question because it's not entirely clear what kind of information from the global scale makes it down to the local scale. So you might be running models that are capable of producing smaller scale variations, but it doesn't mean those variations are right. The downscaling approach, dynamical downscaling approach, has worked very well in places like the Alps or the western United States where there are a lot of mountains and the local climate is influenced by whether you're on the rainy side of the mountain or the dry side of the mountain, high elevation, low elevation. In the flatter parts of the world, of which we are one, it's not clear how well that works. So these are research questions. People will use what methods are available. And at the same time, we're not going to just say, well, we don't know, throw our hands up in the air. Statistical methods are being used, dynamical methods are being used, but what really works is still a research question.
How about one more question?
Hi, Paul Slade, Union County. Just to carry on from what Jeff said in terms of the data, and I think that is correct. As a planner, one of the things that we have to do to form our, administrations and politicians is to show how that data really relates down at the local level. All right, and essentially, the items that people usually understand are economics, and understanding what that impact is at that, of that climate or energy or what have you, and breaking it down, because obviously that has to be also shown to counter what people's perspective is that maybe it's just a fallacy. People believe, well, there's counter information. Some groups of scientists are saying that, obviously the global impact, global warming, what have you, is one aspect, and the other aspect is, well, maybe that's just a natural progression of the environment over time. So to show the data, you have to have more data sets, I think, and to break it down out to that value.
We're going to take a 15-minute break, and there's the...
Yeah.
Oh, I'm sorry, did you have a response? I'm sorry.
Yeah. I have a response.
Okay, go ahead.
One, you can always answer it to the skeptics, if they're open to hearing it, that 98% of the scientists who are publishing in the field agree there's scientific consensus on the observations that climate change is happening, one. And to the second point, to your larger point, I think we're at the point of trying to prioritize, given limited budgets, given the constraints of what's happening locally. How do we prioritize the next steps of what we do in the way of preparedness? Mm-hmm. It seems to me like that's the nature of the conversation we're trying to engage in, and that has to do with coming up with cost estimates of what's most important, and what's most important to the communities most vulnerable to these effects in a given time and place. So you have a response to the skeptics, and then the conversation is, what comes first? What do we do first to protect the people that are most affected?
And again, that is exactly the nature of the dialogue that we hope to have this afternoon in our breakout session.
And I'll say this quickly because we're anxious to get our break in, but when Joe alluded before to this research project that's going on among a variety of people here at Rutgers on regional modeling of climate change, including economic modeling, the whole point of that project is to try to connect what we understand about the physical climate and its impacts and in the economic realm.
I think that as you increase the number of data sets, and then it becomes a little more consistent, as data shows that consistency across.
Good. Okay, so we are taking a break. We're going to be back here at 11 o'clock. Again, please try to keep your cell phone conversations out here to the atrium, and we'll see you in 10 or 15 minutes. Thank you. Thanks to our panel.